Hello everybody, it is time for us to look at the topic 6 review and go through the answers here. Now once again, I'm doing this sort of on my own as I go. I don't have an answer key sitting next to me, so I apologize if it takes me a little bit of time to do the problems just like it takes you. So let's start with the vocab up here. A parallelogram is a blank if its diagonals are perpendicular and congruent. Well, if its diagonals are perpendicular, it's a rhombus, and if it has got congruent diagonals, it's a rectangle. And anything that is both a rhombus and a rectangle is a square. Number 3, a blank is a quadrilateral with 2 pairs of adjacent sides congruent and no pairs of opposite sides congruent. That is a kite. The sum of the measures of the blank angles of a convex polygon, that would be the interior angles of a convex polygon, is that formula. And the length of the blank is the average of its 2 bases. That would be the mid-segment of a trapezoid. All right, let's keep going. Find the sum of the measures of the interior angles and exterior angles. Number 6 is a pentagon. You may have memorized this one. The interior angles have a sum of 540 degrees. The exterior angles always have a sum of 360 degrees. This next shape, we got to count the sides. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's a dodecagon. So we will do n minus 2, 12 minus 2, times 180. That's 10 times 180, or 1800 degrees for the interior. And as always, 360 degrees for the exterior. Number 8, is there enough information to determine the measure of the interior angles of the polygon shown? If so, find the measures. If not, explain. Well, it looks like we have a hexagon here, and we can definitely find the sum of the interior measures of a hexagon. Can do 6 minus 2 times 180, which gives us 4 times 180. So the sum of those angles is 720 degrees. And then we have 2 angles that are 90 degrees. So we'll do 720 minus 180. And that is going to give us 540. And that 540 degrees is going to be split 4 ways, 4 congruent angles. So 540 over 4 will give us 135 degrees. So we found the interior angles are 90 degrees and 135 degrees, and they are both repeated there. Number 9, we're finding the measure of angle 1. Well, we know that this is a kite because it has 2 pairs of adjacent angles, which means we know that the diagonals are perpendicular and that that triangle is a right triangle. So we can do 180 minus 90 minus 31, and we can find that that is going to be 59 degrees. All right. Number 10, BC. So BC is the top of this trapezoid, and we know that the mid-segment is 10. So if we add up the top and bottom, x plus 13, and divide by 2, we will get the length of the mid-segment, which is 10. Then we just solve the equation by multiplying both sides by 2. So x plus 13 equals 20. Subtract 13 from each side. X equals 7. So BC, that top length, equals 7 units. Number 11, Shannon wants to hang curtains using a tension rod across the top of a trapezoid-shaped window that is shown. Is a 36-inch tension rod long enough to go across the top of the window? Well, we can find out since we see that this is a mid-segment. We can tell because this side is brought into the midpoint, and this side we have the midpoint, and we know it's a trapezoid-shaped window. So same thing as last time, x plus 12 over 2 equals 27. Multiply both sides by 2. That's x plus 12 equals 54. Subtract 12 from both sides. X equals 54 minus 12 is 42. Is a 36-inch tension rod long enough? No, because that window is 42 inches long. Number 12, find each angle measure. So in a parallelogram that's marked like this, we know that the angles are going to be supplementary if they're adjacent to each other, like angle W and angle Z. So we can do 180 minus 95, and that will tell us that the measure of angle W is equal to 85 degrees. The measure of angle X will be the opposite angle of the one that we know, so it'll be the same. So that's going to be 95 degrees. Number 14, the outline of a planned parking lot in the shape of a parallelogram is shown. Elijah says the north side of the lot is 130 feet, and the west side of the lot is 240 feet. What is Elijah's mistake? Well, if the outline is a parallelogram, the parallelogram has opposite sides that are congruent, not adjacent sides, which are congruent. So we can say parallelograms have congruent opposite sides not congruent adjacent sides. All right, and that'll be all we need there. Number 15, for what value of x is each quadrilateral a parallelogram? Well, obviously, we're going to need to know that the opposite sides are congruent. So x plus 3 will need to be equal to 2x minus 9, and we can solve that. So 12 equals x, and that means that I know that x is equal to 12, and I can check it on my other two sides. So if I do 3 times 12 plus 4, that will be 36 plus 4, that's 40. If I do 12 plus 28, that is also 40. So x definitely equals 12. I look at this other one, and I know that if this is a parallelogram, the same side or adjacent angles will be supplementary. So I know that 78 plus x plus 54 will be equal to 180, and I could solve that. I also know that 2x plus 6 has to be equal to x plus 54. I can solve this either way. Either way will give me the answer. So if I solve it the first way, 78 plus 54, that's going to be 132 plus x equals 80, and then, or equals 180 rather. Subtract 132 from both sides. X equals 58 degrees. And if I do 2x plus 6 equals x plus 54, it should be the same thing. And it's actually not x equals 58 degrees. It's just x equals 58. It's not a degree measure. So if I subtract x from both sides, I get x plus 6 equals 54. Subtract 6, and I get x equals 48. Oh wait, duh. 180 minus 132 is not 58, it's 48. There we go. So 48 either way, any way you slice it. Number 17, all the black lines in this pattern shown are vertical. What measurements can be used to show that each gray quadrilateral is a parallelogram, and explain? So what we could think about is if all of these lines are vertical, that means that they're all parallel. And we know that if there is one pair of sides that is both parallel and congruent, then the shape must be a parallelogram. So when it says what measurements can be used, we could say the length of the segments where the black lines intersect the gray. That would mean like this segment right here, and this segment right here, and etc. So the length of the segment or segments where the black lines intersect the gray would need to be equal or need to be congruent. Need to be congruent so that they would have congruent and parallel lines. Number 5, let me check some things here. Oh yeah, okay. Number 5, or lesson 5, given that ABCD is a rhombus, what is BD? So if we know that ABCD is a rhombus, we know the diagonals bisect one another. So I know that these triangles have a base of 4 and a hypotenuse of 5, and I can use the Pythagorean theorem. Say x squared plus 4 squared equals 5 squared. And when I solve that, I find that x equals 3. So the length from BE is 3 and E to D is 3. So BD is double that, or 6 units. Number 19, given that PQRS is a rectangle, what is QS? So if this is a rectangle, I know that the diagonals bisect one another, so PR is 12. And I know that the diagonals are congruent, so QS is also 12. Number 20, is any quadrilateral with 4 congruent sides a square? No, because it could also be a rhombus. It could be a rhombus. It's only a square if it's got 90-degree angles. It's only a square if it has 90-degree angles as well. All right. The diagonals of a rhombus are 10x and 12x. What is the perimeter of the rhombus? Ignore this next part because clearly the answer is online now. I actually have it. So we can draw this rhombus if we want. Again, draw your diagrams big enough where you can write in them a little bit at least. They don't need to be super tiny. So those diagonals would be this line and this line. And if the diagonals are 10x and 12x, then half of the diagonals are 5x and 6x. So what we have there is a right triangle with side lengths of 5x and 6x. And we can find the hypotenuse. So we can say 5x squared plus 6x squared equals c squared. That's 25x squared plus 36x squared equals c squared. And that will give me, let's see, 25 plus 36. I should know this off the top of my head. 61x squared equals c squared. But I want to take the square root of both sides. The square root of 61x squared can be written as x root 61, since the square root of 61 is a decimal, but the square root of x squared is just the letter x. And if one side is x root 61, the perimeter of the rhombus is 4 times x root 61, or just 4x root 61 to be the final answer. Then we've got 21 and 22 here. Is this parallelogram a rhombus, a rectangle, or a square? Well, we know it's a parallelogram, so that's nice. Here in number 21, we know that it's a parallelogram with congruent diagonals because each diagonal has 2 segments with a hash mark. Any parallelogram with congruent diagonals is a rectangle. Number 22, we know it's a parallelogram and it has perpendicular diagonals. Any parallelogram with perpendicular diagonals is a rhombus. And we don't know anything else about it. Not trying to put an E on the end. It's not rhombus, it's rhombus. Number 23, for what value of x is GHJK a rhombus? Explain. If it's a rhombus, we know the diagonals are perpendicular. 48 is going to, by alternate interior angles, also be the measure of this angle down here, which means that in that triangle given, it's a 30, not a 30, 60, 90. It's a right triangle, so I can do 180 minus 90, minus 48, and I can find out that that is going to be equal to, or x equals, 32 degrees. Did I do that wrong? Hold on. I can't do math in my head. Minus 90 minus 48. 42 degrees. This is why I always work with an answer key next to me so I don't tell you the wrong thing. Number 24, can Nora construct a kite with diagonals that bisect each other? Explain. She absolutely can, because a kite just has to have two pairs of adjacent congruent sides. If those adjacent congruent sides happen to all be the same length, such as this pair of adjacent congruent sides and this pair of adjacent congruent sides, that makes the kite a rhombus. And a rhombus happens to also be a kind of parallelogram. So we know that in a rhombus, the diagonals must bisect each other. So we can say if the kite is a rhombus, kite is a rhombus, the diagonals bisect each other. There we go. Ooh, we've got some always, sometimes, nevers for these situations. That's always fun. So, always, sometimes, nevers can be tricky because we like to think about certain cases when we should be thinking about all the possible cases and whether all of those are true. So, for example, rectangles are squares. Well, rectangles are sometimes squares and rectangles are sometimes not squares. So we'll say sometimes there. Isosceles trapezoids are parallelograms. Well, an isosceles trapezoid is a trapezoid with the opposite sides the same length and then the two bases still. If we had a rectangle, that would be an isosceles trapezoid. It would also be a type of parallelogram. So one type of isosceles trapezoid is a parallelogram. Isosceles trapezoids are sometimes parallelograms. Rhombuses are always quadrilaterals because they always have four sides. Kites are parallelograms. Well, we just talked about an example of a kite that was also a rhombus, and rhombuses are parallelograms, so kites are sometimes parallelogram shaped. Rectangles are regular quadrilaterals. That's a word we haven't seen in a while. Remember, regular means that all the sides are the same length. So, for example, a regular quadrilateral would be a square. Well, we know rectangles are sometimes squares, so rectangles are sometimes regular quadrilaterals. Quadrilaterals have four congruent angles. Rectangles do. So quadrilaterals sometimes do, they don't always. Rectangles are rhombuses. Let's think, are there rhombuses that are rectangles? Rectangles are squares sometimes, and squares are rhombuses. So rectangles are sometimes rhombuses. Lots of sometimes here. Trapezoids have one pair of opposite sides parallel. Well, considering that's the definition of a trapezoid, that is always true. Trapezoids have one pair of congruent sides if they're isosceles trapezoids. Not every trapezoid is isosceles, so sometimes they have one pair of congruent sides. Kites have two pairs of congruent sides. Again, that's part of the definition of a kite. Kites have two pairs of adjacent congruent sides, so that is always true. Squares are regular quadrilaterals. Squares have all the same side lengths and all the same angle measures. That is always true. Kites have congruent diagonals. Well, there's one type of kite that has congruent diagonals, because if a shape is a square, it happens to be a kite. It has two pairs of adjacent congruent sides, and the diagonals of that shape are congruent. So kites are sometimes, very rarely, only when they're squares, but they're sometimes having congruent diagonals. trapezoids have 4 congruent sides? Well, a trapezoid could have one pair of sides which are congruent and the other pair of sides which are parallel but also congruent. So yeah, we can say sometimes trapezoids have 4 congruent sides. Parallelograms have 4 congruent angles. Some parallelograms are rectangles, so parallelograms sometimes have 4 congruent angles, and other times they don't. So this is more of an always, sometimes statement set instead of always, sometimes, never. But those are what we've got there. And then that is the end of the study guide. Let me know if you've got any questions, and make sure to keep studying with your other resources as well. Have a great day.